Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Hidayah binti Hamri, and now I would like to explain the code. And this is the declaration part. This is declaration for the linked list, declaration for the binary search tree, and the declaration for the grade. And next is for the function. This function is to add a new node into the linked list, and this function also is for the grade. So the function we call is not grade add, and this is the code. Node grade, new node equal to new node grade, new node data equal to data, new node next equal to null, and we return new node. Next is function for the mark, which is we push or insert the mark in the linked list. And all the value of mark, I already put it in a main function. This is all the value mark. I put it in a main function for the 28 student. And this is the struct node malloc. Allocate the size of the struct node. New node data equal to data, new node next equal to head, and head equal to new node. And this is for the push. This is for the add a new node. For the grade, this is to insert a mark in a linked list. Next is the function to convert the string into the linked list, and this function is for the grade. So the data for this function, I also put it in a main function, which is the string text. I put all the grade in a string, and I use the function that I name SLL function to break down this linked list. So this is the function that I said, SLL. So this integer I equal to 1, I less than text size, I plus plus. Next add text I, which is 1, so it will add this, which is B. So, and then after this is for call the grade until the 28 student, and at the same time this is for the print grade in a specific format by adding this arrow. So after it call the grade, and it will display the arrow and continue until 28 student. For the example, I choose linked list and student grade like this. After add a grade, it will print the arrow until 28 student. But if it goes to 29, it will not display anything because 29 is more than text size. So that's all from me. Thank you.
Hello everyone, my name is Farhan Sadid. So now I will explaining the part of add new node and also inserting the node into the binary search tree. In here we are writing the code, which is using the function of an insert node. The insert node consists of the pointer of BST node name as root and insert the data as integer. Okay, let's say that this is very new. There is no root inside the tree, so it will be detect if no root inside the tree or null. So the root will generate the new node using the function of get new node. It will be pushing the data into the tree. What if we are using or we are inserting the new node? Inserting the new node will be, the code will be detecting that the root is lower or higher. If in case that the data is lower than the root data, which is the current or the previous root, so the data will be going here, going into the left and implementing the insert node. So the root will be going to the left and while in the left side, the function will be pushing the data. Else, this part will be pushing the data if the data is bigger and equal from the root. So if the previous number or previous root is higher than the insert data, so it will be going to the right. So after going to the right, the insert node function will insert the data into the root right. The high score and the lowest score in binary search tree. So we are using two functions, which is find min and find max. Find minimum means the lowest score in the binary search tree. So this function will be pointing to the root and will detect that the root will be the current. Okay, if the root is empty or there is no root inside the binary search tree, it will print error message as the error tree is empty. But if there is certain roots have been inserted to the tree, so it will be starting that the current, it's similar like temporary, so the current means root. Well, root will be traveling, the current will be traveling to the left side because the left side is the most smaller number and smaller score. So current will be traveling into the road, into the left. So when the function has found the lowest score, so it will be print current or the most left data and print the output. Next, this is a function of a high score, whereas the high score will be on the right side. So it's similar to the finding the lowest score. The high score will be on the right side, so it will be traveling one by one root. Okay, this is a root. It will finding one by one and will be looping in this while, which is the while will be getting right side. So it will be get the score when the most right, and when the function has found the highest score, which is most right side of the tree, it will be print the data with a pointer or current into the data. So the data will be print out as the very most right side of the tree. Okay, thank you.
For the maximum value in the linked list, we can find it using pointer to the previous nodes. Firstly, we initialize max with int main, which is the lowest value can be stored as an integer. Then we create a while loop, while the head is not null. Then we use if loop to compare max to the data in the first head. If it is smaller, the max will be replaced with the data value of that current node, and we will move to the next head. When we reach the last element of the linked list, the head will be null, which will break the while loop, and max will be returned. For the smallest element in the linked list, we repeat the same idea, but for max we will replace it with main and assign it to int max, which is the largest value as an integer. Then a while loop again to detect the end of the list, and an if loop to compare main to the value of the data in the current head. If main is the biggest, then it will be replaced, and we move to the next node until the end of the list. Then it will return the main value.
My name is Aqilah Hanim binti Mohamed Taufik, and I will now explain how we found the average of nodes in both linked list and also binary search tree. Both of these lists use the same function, which is the average of nodes. So first of all, we float the average of nodes, and then if head equals to null, if it is the head of the list, then return -1. Integer count equals to 0, integer sum equals to 0, float average equals to 0.0, and then struct node current equals to head, while current equals to null. And then sum equals to current data, and then the current data will find the next data. The calculation for finding the average value is average equals to double the sum of marks divided by the number of marks that is inserted and return average. Assalamualaikum warahmatullahi wabarakatuh. My name is Aqilah Hanim binti Mohamed Taufik, and I will now explain how I did the main menu for this program. Firstly, in the main menu there are two options, which is the linked list and also the binary search tree. When you click on linked list, which is 1, another menu will pop up which will display 4 other options, being the student grade, highest mark, lowest mark, and also the average. When you click on the first menu, it will print the student's grade, and when you click on the second menu, it will print the highest mark of student, which is the largest element in the list. Next is the third option, which is the lowest mark of student, also known as the smallest element in the list. Last but not least is the fourth option, which is the average of the marks, and it will print out the average of nodes from the list. Similarly as the linked list, the menu for binary search tree will also display 4 options, which are the student grade, highest mark, lowest mark, and average. The first menu will print out the student grade, the second menu will print out the highest mark of student, and it will be using the functions find max. The third option is lowest mark of student, and it will be using the function find min. And the last option is average of marks, and it will be using the function average of nodes also.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Hidayah binti Hamri, and today I would like to show the demo for our project. This is our main menu. We have 2, which is linked list and binary search tree. Now we choose 1, and it will go to the menu, and we choose student grade. It will display this grade for 28 students. Okay. Next, we choose linked list again. We choose highest mark. Highest mark of student is 89, which is the same with in the student record. We choose linked list again, and now we choose lowest mark. Lowest mark of student is 61, same in the student record. Next, linked list, and we choose average. Average of the mark is 73.8276, which is in the student record is already round off. Next, we go to the binary search tree. We choose main menu 2, and we choose student grade. Same, it will display the grade for 28 students. We choose 2 again, and highest mark. Same also, highest mark of student is 89. We choose 2. Now for lowest mark. Lowest mark of student is 61. And lastly, binary search tree and menu 4, which is average. Also the same, average of the mark is 73.8276. Okay, that's all from us. Thank you.